I want to take a second and just look at a few definitions. These are words you're going to be seeing used within the textbook, so we want to make sure we understand what they mean. First of all, a variable is a letter or symbol that can represent any number from a set. Now, the set that we will start off with will be the set of real numbers, but other sets can be used. The most common variable, of course, you see used is the variable x. Along with that, you see the y used quite a bit. We'll also see other things like k's and t's, but those aren't the only variables, of course. Sometimes you'll see variables from the Greek alphabet like alphas, theta, etc. But remember, if you're using it as a variable, it has to be a letter or symbol that can represent any number from a set, not a fixed value, because that's what a constant is. A constant is a letter, number, or symbol whose value is fixed. Obvious examples would be actual numerical values like 5, 1/2, 9.8, etc. But there are other symbols that represent fixed values. A prime example would be pi. Even though pi is a Greek letter, it represents a set value, so it would not be used as a variable. Pi must be used as a constant. Now, a numerical coefficient is a sign and the number multiplying the variable or variables. For example, in an expression like negative 5x plus 7y, the negative 5 is the numerical coefficient of x. Notice we include the sign. And the positive 7 is the numerical coefficient of y. Now, notice that this definition specifically says multiplying. So in something like x over 3, the numerical coefficient is implied to be a 1/3, not a 3, because the 3 is being divided. So you have to view division by 3 as multiplication by 1/3. So that's sort of a subtlety that you have to watch out for. Now, an expression, our next definition, is any combination of signs, numbers, variables, constants, and operations. Now, with operations, of course, we mean like addition, subtraction, multiplication, division, powers, roots, etc. So if you were to take a constant, a variable, an operation, maybe even another constant, this would count as an expression, because we actually have two operations being multiplication and addition. We have a constant here, we have a constant there. This constant is acting as a numerical coefficient. We have a variable. So this is considered to be an expression. And it really doesn't take much to make an expression. You can just put in a constant and have that considered to be an expression. A constant and one variable is considered to be an expression. It's not an equation until there's an equals to. So if I was to take the first expression, set it equal to the second expression, that would be considered to be an equation. Again, if it doesn't have the equal to, it's not an equation. And it is important that we can tell the difference between these two. Equations are what we will attempt to solve. If it's not an equation, we're not trying to solve it. Expressions, therefore, by default, can't be solved. They don't have an equal to. You don't have two sides to work with. You don't have an equation. You can't solve it. Expressions can be evaluated. I could say let x equal 2, plug it in, and evaluate. So I've evaluated this expression to be 11 when you put in a 2. Expressions can also be simplified. A 3x plus a 2x would give me a 5x. So expressions can be evaluated, they can be simplified. There are other things you can do with expressions, but they can't be solved. Only an equation can be solved.